So in this video we will be parsing the exports from the DLL. If you generate a DLL using the Metasploit, it won't have any exports, so it's kind of like exe but a DLL. So that's why I have taken this MSVC runtime 120.dll. So we will be parsing all of these export functions. So if you go to optional header in the data directory, we have the starting one is the export directory. So it has the address and it has the size. So if I click on this address, I will go to this array. Now here we have these, you can parse these into this export descriptor. So the characteristics is 0, and you can parse these as well, time, date, stamp, and the important one is the name, so DLL. So then we will have the number of functions, number of names, number of address of functions, address of names, and name address. So these number of functions define the total number of functions that the DLL is exporting, and the number of names is how many functions that are being exported via name. So the function can also be exported via name ordinal without having any name to it. But in our case, you can see both are 785. That means all functions are exported via names. And here we have address of functions. So if you go to this, you will have array of addresses where each belongs to the string. Sorry, the function address. And the address of names contains the array of addresses, and if you go to the address you will find these strings, and address of name ordinals. So here we will have index to this array. So what we're going to do is let's first go to the address of names, and you can see the first 4 bytes D2507. So D2507 is this one. So if I click on this one, I will be redirected to this function name. And to find the address of this function, what you need to do is you need to look up at the name ordinals. The first parallel to this, this is the first element, and you need to look at the first element in the address of name ordinals, that is 0. So go to the 0 index of this address of functions. So 0 index of this address of functions, if I go to this, I will have this array, and if I go to the first element, that is this 4 bytes 07E798. So 7E798, if I go, and that will be the address. So here we can see it looks like a function call. So this is the function address, and the similar way for the second element. The second element is D1325 D2513, sorry. So this is the second function, and if you go to the second element of this one, you will have this address. So the address is 14C8. So 14C8 is the function array. So we are going to pass this information. So first let's go to the optional header and get this data directory. So we have already parsed all of these headers previously. So we can say nt header dot optional header dot export table dot virtual address. So this gives you this one virtual address. So we can say long export offset. So we have this offset. If you add it to the base address, you will be taken to this one. So what we can do is we can marshal this one, marshal dot pointer to structure, and the first one is the pointer. We need to point this one, So base address dot 2 in 64 plus export offset, so that gives you this one. So we have this one. Let's convert this to into pointer, and we need to marshal as the export directory, image export directory. Export is equals to, so we have the we have some error here. Okay, we have the export. So also this export offset should not be 0, so this export offset will be 0 if in the case of exes. If export offset not is equals to 0, then only parse the image export directory. Now the name is this one. So what we can do is base address plus export dot name. So if you combine the base address plus this one, you will get the address pointing at this starting of the string, and then you can convert this into string, marshal dot pointer to string and C. Now let's store this as string DLL name. Now I am going to print the DLL name. So we should get the this DLL name. So let's run this. Sorry. Let's run this, and we can see the exported DLL name. Now we can go and parse these functions. So let's first normally print out all the functions, function names. We can also print number of functions, export dot number of functions dot to string. And number of names. So let's go and run this, and we can see 785 785, so in hexadecimal. Now let's go and print all of these names. So address of names, if you go to this, I will have array of addresses, and I need to marshal these the content at this address to the string. So export dot address of names. So if I add base address to this one, I will get exact address, at this first function name. So I can loop over these number of functions. For int I is equals to 0, I less than export dot number of functions I plus plus. So I'm going to loop over this. So this is a pointer, so Marshall dot pointer to string ANSI and specify this pointer. String function name. Now let's go and print this. So we are not incrementing now, we are just printing out the function name for now. Let's run this. Okay, we need to read the 4 bytes, right? So not at this. So let's cut this one. We need to read the contents at this array. So Marshall dot read int 32. Now I am reading that address. Now I get the value, this D2507. So that will be stored in, let's say, int function offset. I can say function offset. If I go and run this, so I think I found the error what we are doing. We are not adding the base address to this function offset. So sorry for that. Actually we are reading only the function offset. I forgot to add this base address to this one. Now if we go and run this, and we can see the function name. Now I can loop through this export dot number of functions. Each time I am looping, I need to add 4 bytes, because I need to read all through these 4 bytes at a time. So how I can do is, I can say plus I into 4. Since I starts with 0 and ends with number of functions -1, we can say I into 4. So at the first iteration it takes 0, and second iteration 4, 8, etc. If I go and run this, so let's cut this and paste here. Okay, we should cut this and paste here. So sorry for this. Let's run this, and here we can see all of the functions. So why? Because we need to increment at this function offset. So we are moving the function offset by 4. So I think we are good to go. The function name. Now what we are going to do is we are going to resolve these name ordinals. So let's say int index ordinal is equals to Marshall dot read int 32 int pointer and base address plus export dot address of name ordinals. So this should give you the offset to the first ordinal. We can also add I into 2. So to get every index ordinal, so it is only 2 bytes 0 0 0 1 0 2 0 3 so on. So we have the index ordinal. Now we want to loop through these address of functions. So similarly you can copy all of this and paste here. So instead of address of name ordinals, we can specify address of functions, and we want to loop over 4 bytes at a time. We are going to get int function address offset. We can call this as function name offset. So for this function there is an ordinal 0, and we need to go to this array at the 0 index, that is the first element. So for this function for this output first function, the index ordinal will be 0, and we need to use this as an index to this function array. So what we can do is we can say instead of I index ordinal. So we are accessing the index ordinals element in this array. So we have the function address offset. So we can go and print this function address offset. So we can say function name and the index ordinal and the address, that is so the function name is the first and the index ordinal and the function address offset, convert this to string. So I think we are good to go now. So let's go and print this. We got an error. Okay, sorry again. So this is also the array. So if you go to this one, you will have this array of these addresses, and you need to read again. So marshal.read int 32. So we are going to read again. So the function address offset gives you at here. So at here we need to read 4 bytes at a time. So we can say base address plus function address offset plus, now we can say index ordinal into 4. Function address. So I think we are good to go. So let's run this. Oh, it's 2. So now we can see we got the function name and the index ordinal and the address. I think we got somewhat wrong, I guess. Okay, we are adding it to the base address, so that's why we are getting more values. So let's comment out this one. Now let's run this, and now we can see we got this address 7E798, that is the function offset 14C8, 14C8 and CC4. So we got the same function offset. So according to the index ordinal we got some wrong. So let's also fix that index ordinal. So we are doing something wrong with this index ordinal. So if you go to the base address press this offset, you will have this one, base address plus index, this one. You don't need to do like this. We can read int 16. So we can directly read 2 bytes at this address. So if we run this, we are printing only the one element, so we need to add I into 2 as well. So let's run this, and we can see now the index ordinals are correct. So 0, 1, 2, etc. So we can, instead of the I, we can do index ordinal. So we will be printing the correct offsets for these functions. So we can see we got successfully parsed the exported functions in a DLL.